All right, here we go. Trigonometry, Algebra 2. This is the second video on circles, talking about the unit circle. If you didn't see the last video, well, there's a link below. You can look at the last video. So anyway, adding more to the unit circle. Let's get a good circle up, and let's get our pen working here. Why don't we try green today? So let's make the x and y plane. Attempt to make it anyway. And we'll pretend that's the center of the circle. So we know that's the x, that's the y, and just going over, we know these coordinates over here. I'll just put those coordinates in. And we know that this one is 1, 0, because remember, it's a unit circle. So the radius is 1. This radius over here is 1. Every radii that you can make on a unit circle would be 1. And this, of course, we have the x is 0, and then the y is 1, so that's 0, 1. And over here, just fix these lines here. Over here, of course, it'll be negative 1, 0. And what do you think this one would be? Fix that line. What would that be? Well, it'll be 0, negative 1. All right, so those are the coordinates over there on the edges. So remember, one of the things, again, unit circle, unit does mean 1. One thing you should know is that we want to go from degrees, because we'll be using radians a lot. So you should know how to go from degrees to radians like we did in the last video. So let's change the color, use red. So over here, let's see if you can take, let's say you had 50 degrees. If it was 50 degrees in the winter, that wouldn't be bad. But anyway, 50 degrees, how would you convert it to radians? So if you don't know how to do that, you can look back at the last video, or I'll do it right now. So the formula is you want to take the degree and you want to times it by pi over 180. That's what you do. So we have 50 degrees times pi over 180. What'd you get? Just plug it in, right? So when you put that through, you'll get 5 over 18 pi. Or you could say 5 pi over 18. 5 pi over 18 is 50 degrees. Let's do another one. Let's clear that out. Clear it out. And what if I gave you, and we'll keep green. What if I said that you had pi over 4 radians? How would you put it to degrees? So with this, you'll take the radians and you're going to times it by 180 over pi. It's a little different. Remember, with degrees, we had pi over 180. So what do you think this answer would be if we had pi over 4 radians? Try to pause the tape. Try to do that. Well, again, we had pi over 4 radians, timesing it by 180 over pi, and the pi's cross out. So now you have 180 over 4, and you'll have 45 degrees. So you should be familiar with translating and converting radians to degrees and vice versa. All right, let's get back to this circle. And we'll clear that out. Maybe we'll use this color. Use that color, why not? All right, so again, making my x and y plane. There's my x, there's my y. And remember, I said every radius you make, every radii has a length of 1. Right, so that would be a length of 1 because it's a unit circle. So if we're making an angle here, we have our degree angle here. We'll say angle theta. And a lot of times you'll hear it as angle theta, Greek letter. Sometimes you'll have it as angle alpha. Could be angle anything, actually. It could be angle gamma, could be angle beta, whatever the case may be. It just means you don't know what the degree is. So we have our angle theta, and we know our hypotenuse is 1. And we can use that, actually, if we want to find the coordinates of, let's say, a right triangle that I just created here. So we'll go over that. But before we go over that, let me make sure that you understand these trig functions. So let me make a big right triangle here. And let's say we have that it's 3 over here. The length is 3. We don't know what the hypotenuse is. And we have this angle theta over here, some degree. So remember, when we're using trig ratios, sine on the calculator, that's what the button you'll see on the calculator. So we'll say sine theta, because we don't know what the degree is. It's going to equal the opposite over the hypotenuse. Change my color to blue here. So opposite of theta, opposite of it, here's the looking right opposite, we're seeing a 3. That's what's opposite theta. So we know it's a 3. And the hypotenuse is x. So we could say that sine theta right now is 3 over x. Now cosine, you'll see it as cos. And cosine, and we'll just put theta because we don't know the degree, is adjacent over the hypotenuse. So let's say we just added a 4 here. So if we're looking at adjacent, it's right next to, use another color. So if you're here, right next to cosine theta is 4. So it'll be 4, and of course we don't know what the hypotenuse is. So the other one is tan. Tan is the opposite over adjacent. So if we're using the same right triangle here, if this was what we're looking for, tan theta, then the opposite is 3, the adjacent is 4. See how we did that? And I'm sure you know that. So let's take this now and put it in the unit circle. I created a right triangle, as you can see here. Go back to that color. So we're trying to find that coordinate. Let's change it, actually, put green. That coordinate and that coordinate. Trying to find that. I'll keep green. So over here, we could just put A, and over here, we could put B. So we're trying to find out what the length of A is, and over here, we're trying to find the length of B. Now, sometimes you'll have them as just X and Y. Now, let's look at this really carefully. Let's look at this coordinate right over here. This coordinate, of course, would be X and Y, because that's how you get a coordinate. And then if we put a dotted line over here, this is the Y. So whatever this length from right here in the center, all the way up to this green, to this Y, that's the length of A. That'll be the coordinate for Y. And of course, the same is here for X. This coordinate is also XY. And you know this stuff. Okay. So if I wanted to find sine theta, here's sine. Opposite of sine is A. That's the opposite. And the hypotenuse is 1. Anything over 1 is that same number. So sine theta is A. Keep that in mind. Cosine theta. Cosine here is adjacent, right next to. That'll be B. And hypotenuse is 1. So cosine theta is B. Very important to know that. So I'll review that again. Let me review that again. So here is the angle theta we're saying. It could be angle alpha, whatever. And opposite, where this line's going, opposite of that angle is A. Opposite is A, and the hypotenuse is 1. Remember, over here, sine is opposite over hypotenuse. A over 1 gives us A. And cosine theta, here's cosine. Cosine uses adjacent. Adjacent is right next to it, and it's B. Remember over here, cosine is adjacent over hypotenuse. b over 1 is just b. Let me clear this out. I'll show you another way. Clearing it out, we'll use red. Why don't we use red? Make another line. A rough graph here. Pretend that's the circle, the center of the circle. And again, I'll make my angle. Trying to find, well, that's a bad line. Darken it in, make it look better. So here he is. I made my right angle here. Trying to find that coordinate. Trying to find that coordinate. There's my angle. Maybe I'll make it angle alpha. Doesn't really matter. And we could have this being x, since it's the x graph, and that's y. Right? That's the y line. That's the x line. And we're trying to find the coordinates. Trying to find the coordinates. So we already said that sine theta, in this case sine alpha, was a. Or, in this case, you don't see an a, you see a y. So it's just y. Sine alpha is y. Some of you might get confused with all these letters, these Greek letters. Just review the tape. Cosine alpha, or cosine theta, we said, was b, or x, or whatever you put here, whatever you're putting in there. Let me do it again. I'll clear it out. I'll use blue. Try to get it straight. There we go. There's our center. Making hypotenuse over here. Making a right angle. Making an angle here. We'll say, let's keep it alpha. An opposite alpha, we'll say, is y. It's the length of that y. And adjacent to it, we'll say, is x. From here to here, that length x. So sine alpha, opposite over hypotenuse. Sine alpha is y is opposite. Remember, the hypotenuse is 1. So y over 1 is just y. So tell me, what about cosine alpha? Remember, you don't care what it is. If it's theta, if it's alpha, it's gamma, if it's any letter they put there. It's just saying we don't know the degree. So what's cosine? What do you remember as the ratio? It's adjacent over hypotenuse. And what's adjacent to alpha? X over 1. The hypotenuse is 1, which just gives us x. So now we know that sine alpha, this one, or a lot of times they use this theta, is just going to be y. And I'll use purple for the other one. And cosine alpha, and sometimes, again, like I said, they use theta a lot, so you might see cosine theta is just x. Very important to look at that. And now let me add tangent. Tangent, and we can use alpha, why not? Tangent is opposite over adjacent. So what is opposite? Opposite was the y, and adjacent was the x. Tan alpha, so look at the y. What is y? Sine. So it'll be sine alpha over cosine alpha. Because remember, what is x? Cosine theta or cosine alpha. Could be confusing. Sometimes you just have to rewind the tape. You'll get it. It'll come to you. All right, now the next part is our second part of it, is looking at the standard unit circle. We're going to look at the unit circle, and let's say we have certain degrees. So we'll look at a 45 degree and a 30 degree, because those are special triangles, and you probably know about special triangles. If you don't, I'll go over it. So let's clear this out. Let's use that magenta color, whatever that is. And again, I'll make my line here, my x and y graph. And let's say now we have a line going up, and it's 45 degrees. And we have our angle here. Let's say angle theta. Keep angle theta for now. Now, we should know what the radians are for 45 degrees. We did that earlier in the video, remember? So if you have 45 degrees, how do you get the radians? Do you remember? Remember the formula? Degree equals what? Pi over 180. Pi over 180. So it's going to be 45 times pi over 180. Not equals. Times. And what do you get? If you multiply that, you're going to say that 45 degrees equals in radians pi over 4. Pi over 4. Now, 90 degrees, what do you think 90 degrees would be? Because it's 45 more. If we cut these up into, I'm going to cut these lines up and I'll show you something. So 90 degrees, let's use the formula before you see if you see a pattern. What do you see here? Right? You're going to see pi over 2. And if we keep going, 3 pi over 4. Just multiply the degrees. You'll see what I got there. And if we go all the way to 180 degrees, we'll just have pi. And if we go to 360 degrees, remember, if we have 1 pi from here, half a semicircle is pi, then a full circle must be what? Using logic, 2 pi. So these are all the radians. So look at that for a minute, and I'll continue. So we had pi over 4. This would have been 2 pi over 2. Cancel that out. This over here now would be 5/4 pi. This one would have been 4 pi over 4. You cancel that out, you just get pi. This would have been 6 over 4 pi. Keep going, 6 over 4 pi. Reduce it, it's 3 over 2 pi. So now what's this one? What do you think that one would be? You got it, 7 over 4 pi. And this would be 8 over 4 pi, and you reduce that, you just get 2 pi. So we went from pi over 4, and this would have been 2 pi over 4, which becomes pi over 2, and so on. So you see the pattern. All right, moving on. What if you had 30 degrees? Just make another line here. What if it was, let's say it's there, 30 degrees. What is the radians for 30 degrees? Try it out. 30 times what? Pi over 180, that's it. What do you think you get? Right, you get pi over 6. Pi over 6. And then you can cut this up into sixths, right? So just following that pattern, what do you think 60 degrees would be? Just without doing the formula, what do you think it would be? Let me clear it out. I'll do it again. And what do you think it is, right? So let's clear that out and make it again. And just follow the pattern on it. And we use green. So we made, let's say we made 30 degrees over here, 60 degrees over here. Remember when we did the formula, we said 30 times pi over 180, and that gave us pi over 6. So 60 degrees will be 2 pi over 6, right? And you reduce it, so it just becomes pi over 3. If you keep doing by sixes, remember, just make sixes. We can get 2 more in here. So that's 90 degrees. What would 90 degrees be? 3 pi over 6. So we already did this before, which is just pi over 2. Now we have 120. What's 120? 4 pi over 6. Then we get 5 pi over 6 and 6 pi over 6. So we can see the patterns that we're making with 6s before we made them with 4s. Now in the next video, we're going to take special triangles, the 45, 45, 90, and the 30, 60, 90, and put them on the unit circle and find coordinates.